Okay, so this is a problem that Michael Penn left not in his last video, like 2 videos ago, as an exercise to the viewer, and I thought, well, this is worth a video response, right? Because it's pretty cool of a problem. So, right, so this is what we have to prove. We have to prove that ln of sine of x is equal to negative the sum of 1 upon n cosine of 2nx minus ln 2 from 1 to infinity, right? So we have to prove that, and yeah, so let's just start, right? Okay, so I'm gonna start by like simplifying this summation. So we start, okay, so let me just write it out here, right? And we're not going to take the minus sign first, we're going to consider it after we simplify the summation, because I don't know, I'm lazy. Anyways, so just write this out here. The sum from 1 to infinity of 1 upon n times cosine of 2nx minus ln 2, right? Okay. Oh no, wait, we're not taking the minus ln 2 here. Sorry, I forgot that. Yeah. So okay, so for the first part, we're going to convert this cosine into the complex definition of the cosine function. It's not that tough to prove it if you have Euler's formula or Euler's formula, or, well, I guess something on those lines. You can prove it easily, pretty much. So n equals 1 to infinity 1 upon n times, okay, so we have e to the I 2nx. Wait, okay, let me remember. Was it plus or was it minus? It was plus, wasn't it? Yeah, it was plus. Okay, plus e to the minus I 2nx upon 2, right? That's the formula for cosine of it. Okay, though, I guess I can just mention it as a side note here. Cosine of x, just in case you did not know this, which you should, is equal to e to the ix plus e to the minus ix upon 2. Just like an FYI, sine of x is equal to e to the ix minus e to the minus ix upon 2i, if I'm not wrong. Yeah, that's true. Okay, so just for your reference, I've written those out. I'm gonna rub them off now because I don't want to waste space. This is going to take a lot of space, as you'd expect. This is not that concise of a problem, right? But it's not that tough either if you're like fluent in calculus and stuff like that. Okay, so we get that, right? So now it's safe to remove the 1/2, and then we can split this into two summations. So I'm gonna do that. Half, and then the sum of n from n equals 1 to infinity of e to the I 2x to the n upon n, right? We can take this n up, take this n in the exponent by exponent rules, basic exponent rules, and we remove the half. So it's easy to see this. Yeah, why am I saying it, honestly? Okay, so we get now plus sum from 1 to infinity e to the minus I 2x to the n, right? Let's close off this bracket. Let me just see that. Yeah, that looks about right. Okay, so first we'll consider this first integral, right? So consider yeah, the sum from 1 to infinity e to the I 2x to the n upon n. Now I'm gonna make a substitution here, right? So we're gonna do let u equal e to the I 2x, right? So this would imply, now we get the sum from 1 to infinity of u to the n upon n, and of course I think it's easy to see now that this is equal to the sum from 1 to infinity of the integral of u to the n minus 1. Wait, no. Let's just verify that, right? Okay. Integral u n minus 1, right? So we get u to the n plus 1 minus 1 and yeah, okay, so that's correct. Just a slight verification there. It's not that tough to see that, honestly, but I'm just not that good at calculus. I want to make sure I'm not making mistakes. Right, so we got that. Now we'll solve this integral. Okay, yeah, I think I should say du here, right? Okay, so du. Wait. Okay, so I think I'm gonna change the order of the sum and the integral because it doesn't matter, right? Exactly. In fact, I think the integral being outside is the correct part. Yeah, okay, I just messed up big time. Well, so yeah, we're gonna take n equals 1 to infinity. Okay, yeah, now it makes sense, right? So now we're just gonna change the indexing. There's going to be n equals 0, right? So we're gonna yeah, so this becomes u to the n, and now of course integrating u to the n. Sorry, now this is a geometric series. Sorry, yeah. Pardon. God damn it. So yeah, this is just a simple geometric series. So you can evaluate this part. It's pretty easy. I think it's 1 upon 1 minus u and du. This is what we have so far, right? Okay. Focus. Yes, okay. So from here we have, right, so now we'll integrate this, right? So now make a t substitution, right? So let t equal 1 minus u dt equals minus du, right? So du is minus dt, right? So from this substitution we get the integral 1 upon t and of course negative sign in front, right, because negative dt. So, and that's of course easy enough. It's minus ln of t. We are going to take the plus c because I'm lazy. Right, so now we'll back substitute. Okay, so now this becomes negative ln of, let's see, 1 minus u, right? And what was u? I'll check back here. We get minus ln of 1 minus e to the I 2x. Cool. So that's what we have for the first part. This is an important part of the calculation. Oh, that box was not well made. Anyways, so now we take the second part, the second sum, and this should be quite similar. I'm not going to leave it an exercise. I'm trying to do everything because, well, why not? Right, so n equals 1 to infinity. It's going to be literally pretty much the same thing. Minus I 2x to the n upon n. Of course, I'm going to leave some part out, right? Because okay, so from here, well, you'll see. So, let w, call it w, equal e to the minus I 2x. And of course, from here you get the sum of w to the n upon, from 1 to infinity of w to the n upon n. But then again, that's the same thing, you integrate and stuff and you get back here. But I'm still gonna write the first step, right? I'm writing till the sum, and then of course it's literally the same procedure, right? So w to the n upon n. So just apply the same procedure. It's not that tough to see now that our result will be, wait, let me just do a dot 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 here, dot dot dot, our result will be negative ln of 1 minus w, which is negative ln of 1 minus e to the minus I 2x. That's a well-made box. Okay, so moving on from boxes, right, so we can see that in that part. Pretty good. So now I think we'll back substitute into this part. Okay, so we get a half. You just like draw a line here. Yeah. I should draw a line here to just indicate that I'm done with evaluating the summations. So a half minus ln. You know, I'm gonna factor out the negative signs. Negative 1, sorry. Negative 1, so ln of 1 minus e to the I to x plus ln of 1 minus e to the minus I to x. Yeah, another bracket there to close off that stuff. Okay, that's hopefully not that tough to see that, you know, where that's coming from, because, well, it's literally what I did right now. So okay, anyways, we've got quite far into this. Now we just have to like simplify this expression and we're pretty much done. But it's not like that easy to simplify this expression. So first we'll use logarithm, the rules of logarithm, properties of logarithm, to you know, combine these two logarithms. So I'm gonna save some space. Half of ln of, okay, no, yeah, I'm gonna need like bigger brackets now. So yeah, I'm gonna use bigger brackets. So that, and then the square bracket, and then the normal. So yeah, they multiply together, right? Sum of two logarithms is the product of their insides, I guess. Sounds weird, but it's true. You can, okay, I can't talk, can I? I 2x. Okay, brilliant commentary aside. Okay, so that's our expression. Oh wait, negative 1/2. Right, that's cool. So from here we have to just multiply these two. Yeah, I guess they're binomials. Okay, so now it shouldn't be that hard to see how I'm multiplying them. Ln of, okay, so we get 1, then a negative e to the minus I to x, then a negative e to the I to x, then a positive 1. Okay, so that bracket is this bracket. Yeah, just my brackets are brilliant, honestly. Okay, so right, we combine these ones because it should be evident why. Please. Imagine someone asking, why did you combine those ones together? Okay, so 2. Now I'm going to I'm going to factor out a negative sign from these two terms, this one and this one, and we're going to get an e to the minus I to x plus e to the positive I to x. Okay, right, that's pretty good. So yeah, we know that. Okay, so I wrote that cosine formula there, right? So cosine or cox, apparently. Cosine of x is equal to e to the minus I to x plus e to the I to x. Right, not 2. I remove that 2 upon 2. So we multiply both sides by 2. We get 2, and then this stuff, and this stuff is the stuff we have here. If that's English, actually, I don't even know if that's like English. So yeah, basically it's cosine of 2x, 2 times cosine of 2x. Pardon. 2 times cosine of 2x is what we get for this part, right? So rewriting everything, okay, so we get ln 2 minus 2 cosine of 2x, a lot of 2's here. Okay, that's pretty good. Now we'll simplify this part, and this is like tricky simplification, right? It's not that easy. So wait, did I say tricky or did I say tricky? Because the G is pretty cool, right? Like a tricky simplification. Yeah, that's pretty cool. That's how you make sense of slurs. Yes, you justify them. So anyways, moving on to math. So yeah, we can write this 2 as sine squared x plus cosine squared x times whole thing times 2, right? Because that's an identity. Please learn trigonometry if you want to understand this. Right, so ln of, okay, so 2 times sine squared x, wait, yeah, okay, in frame, plus 2 times cosine squared x, and then we have an identity for cosine of 2x too, I'm pretty sure. It's like cosine squared x minus sine squared x. Yes, okay, so minus 2 cosine squared x minus 2 sine squared x. Yeah, I should put brackets around all these x's, right? Yeah, okay, that's that closed off. Then another bracket for the ln, then the bracket for the, okay, that's a lot of brackets. That's like 4 brackets together. Decode that stuff. Okay, so now it's pretty clear that we can cancel these two, right? That's exactly why we did that. And then of course this plus and this this minus and this minus combine to become a plus, because -1 times -1 is +1, right? So okay, so we can write this as -half, okay, ln of 4 sine squared x. Okay, so we have less brackets. I guess that's pretty cool. Brackets, this is the meta now. Okay, so right, so a property of logarithms is, okay, so a ln b can be written as ln of b to the a. That's like a major property of logarithms, so we're going to use it here for this 1/2. So we're gonna take a square root inside. Okay, so take this power of 1/2 inside the logarithm, so take a square root of this part, and I'm gonna skip that step because I am not an elementary school student. So it's gonna be negative ln of 2 sine x, right? Yes, that's true. Okay, and of course now because we have to like separate the well, I guess, yeah, you'll know why I'm doing this. For now, just suppose I want it to look better, so ln of 2, and of course we can separate these logarithm properties, minus ln of sine of x. Okay, so now we're pretty much done. Now we just have to plug this in, and we have to remember that this thing that we have here is equivalent to this sum, right? Okay, so plugging that in there, we get ln of sine of x is equal to, okay, so we get negative of negative ln 2 minus ln sine x, that's that closed off. Then another bracket, too many brackets, I swear. brackets will take over the world at some point. Okay, so that's pretty cool. Right, so now we simplify. Ln of sine of x is equal to, okay, so this is a positive ln. I'm just gonna write it out, right? So ln of sine of x, brackets, okay, and then a positive ln2 and a negative ln2, and of course, boom, ln2 cancel because they are additive inverses of each other. That's, I guess. Or I guess you can like overcomplicate this and you can say, okay, you know what, I'm gonna overcomplicate it because I want people's heads to hurt. I am a sadist. YouTube, don't flag me. ln2 minus ln2. So we're gonna use properties of logarithm, right? Okay, so this is going to be fun. Ln sine of x is equal to ln sine of x plus, okay, so we can combine these, right? So ln of 2 upon 2. Well, 2 upon 2, that's 1, and of course that's going to be 0, but shouldn't fill out this entire board because, yeah, I just want to. There doesn't have to be a reason. And then of course plus, okay, plus 0. No, wait, plus ln of 1. Now 1 can be written as e to the 0 power, and yeah, okay, I'm just done at this point. Okay, so we just proved that ln of sine of x is equal to ln of sine of x, and that, ladies and gentlemen, is the proof completed. To quote Michael Penn, okay, that's a good place to stop or something. Man, I can't remember. Okay, yeah, that's pretty nice though overall. Like, yeah, I like that proof. I had it ready for like 2 days, by the way. I just couldn't get a good environment to record in, so yes, that's what you get, right? 3 days late. And yeah, that worked out though. Right? That's a pretty cool proof. Nice.